So our first common radian measure is 2 pi. And then I was like, wait a second, what if we just take that 2 pi, or that angle rather. So again, I'm drawing an angle in standard position. That just means that your initial side is on that positive x-axis there. What if I just took that ray and I rotated it halfway through the circle? Well, that's not 2 pi anymore. Does anybody remember what that is? Pi. Delicious. So pi is like 180 degrees, right? So 2 pi, 1 pi. Then we started to cut our pi's in half, right? So maybe even moving into another angle family. Let's draw our angle in standard position again. And this way, or on this diagram here, I'm only going to pass through quadrant 1, putting my terminal side on the positive y-axis. It is pi over 2. Nice job. So that's our other angle family. So we had pi over 2, pi. Down here is our 3 pi over 2. So those are our pi over 2s, if I continue to rotate that ray all the way through. But this one here, 90 degrees, is pi over 2 radians. Okay, then we took that half and cut it in half. So we took pi over 2, and this is where our 45-degree angle was the other day in degrees. So we were taking half of our half of pi over 2. Do you remember what family that was? Pi over 4. Nice job. So if you take a half of a half, you're looking at a fourth. And then these last two circles are kind of in the same sort of function family. The first little one is our 30-degree angle. And our 30-degree angle yesterday was our pi over 6 family. But if I double that and go to 60 degrees, we started counting off by pi over 6's, and we got our last angle family. So if this was 1 pi over 6, this guy up here was 2 pi over 6, but we didn't write it like that. Pi over 3, nice job. So that was that last family. So we have our pi over 3's, our pi over 6's, our pi over 4's, our pi over 2's, and lastly we have our whole pi's, 1 pi and 2 pi. So those are our very common radian measures, the most famous ones. So you on that little participation quiz I was going to give you a little later. A little bit of vocabulary. Remember any acute angle? Just to review with you. Remember, acute means, oh, it's little, small, like a cute puppy. Acute angles are little too. If we're doing degrees, we're talking somewhere between 0 degrees and 90 degrees. That theta is our angle measure. But in radians, we'd be talking 0 radians to pi over 2. So basically, we're talking any angle hanging out in quadrant 1. So, for instance, a great example of an acute angle, going back to our common measures here, that angle right in there that I just drew was 45 degrees a couple days ago. Today we know it and love it as pi over 4. Less than 90, hanging out in quadrant 1 there, super cute. So we call it acute. If you're an obtuse personality, your personality fills the room, it's very large. Maybe you have some very obtuse friends. You might not call them that, but you know who they are. They're just like, they feel like they're omnipresent. They're like everywhere. So obtuse personalities or big personalities. Obtuse angles are big angles. So these are going to be our angles that are bigger than 90. So we would say theta is greater than 90 degrees. Or we could say, in radians, we're talking bigger than pi over 2. We don't normally talk about acute and obtuse with regard to negative rotation. So that's a little side note. We usually classify them when they're in positive rotation, which would mean finding a coterminal angle, and that's my next vocab term. I'll get to that in just a second. So obtuse, let's pick a good one here. Let's do, well, hi, glitchy little app here. I'm going to draw my angle in standard position. This time around, I'm going to drop it all the way down here. And what I did is I came back 30 degrees from 270. So it's one of your famous angles. Hopefully you're starting to memorize. It's 240 degrees. And that would also be, in radian measures, our 4 pi over 3 angle from yesterday's lesson. Big rotation. Okay, once again, coterminal angles are angles that have the same terminal side or stopping spot. So when we're in radian measure, notice you've copied this definition before. When we're in radian measure, we want to add or subtract 2 pi radians in order to find them. We do this because 2 pi radians is precisely 1 revolution. So it's like you're spinning the spinner one more time. So let's say, oh, I thought there was an example over here. We're gonna, to find them in radians, what we're saying is we add or subtract 2 pi radians, but just a little throwback, in degree measure, we would add or subtract 360 degrees. And it's because these two things both indicate 1 revolution. You're spinning that spinner one more time around. Sometimes it's important to help us, classify our quadrants, and you guys have been pretty good about this. But to make it official, quadrant 1 is where your x-coordinates and your y-coordinates are both positive. Quadrant 2 is where your x-coordinates are negative, but your y-coordinates are positive. I wrote a positive y there. We don't need all that. So your y-coordinates are positive there. If you'll recall, in quadrant 3, both x and y are negative. And then in quadrant 4, to count off ordered pairs in quadrant 4, we count positive x values, but we go down into negative y values. And that'll be important in a couple days. As a class yesterday, we spent some quality time going over example 1, right? So that one's done. Did we get all the way through it? Did I do G and H? Okay, I couldn't remember if we talked about how those are like actually the number of pieces of string that it takes us to get through the entire circle. So 2 radians is like 2 radiuses. You take your string and you wrap it around twice. What quadrant does that land in? Just to review, that's quadrant 2. So, little heads up there. Couple skills. I just wanted to review finding coterminal angles this time around, just in case. We're going to talk about it in radian measure, and then I slid 1 degree example. So here in example 2, I'm supposed to identify 2 coterminal angles, one that's positive and one that's negative. So here, we kind of know where 4 pi over 3 is on the circle. Well, let's say we wanted to find another angle, or 2 in this case, that land in the exact same spot. Well, remember that to do that, you're going to take your 4 pi over 3, and like we said in the vocabulary, you would add on 1 revolution. In this case, we'd be adding on 2 pi, because it's already in radians. So again, that was 1 revolution. You can't find a coterminal angle unless you're finding an angle that has that same stopping spot. And a couple of you are a little bit fraction phobic, so, I'll bust out the butterfly. 4 pi times 1 is 4 pi, so that's that antenna. And then 2 pi times 3 is 6 pi, so that's that antenna. And then every butterfly needs a butt. 3 times 1 is 3. So if I'm adding these, 4 pi plus 6 pi is 10 pi. And then the butt just comes along for a ride. So that's 3. Let's practice it with subtracting. So it does say to find 1 positive and 1 negative coterminal angle. So 10 pi over 3, that's a positive number. I'm good. Now I got to do 4 pi over 3 and subtract 1 revolution. In other words, I got to subtract 2 pi over 1. So you could do the butterfly again. Whee. And we got 4 pi, still 6 pi. We're just going to subtract the antenna now. Every butterfly needs a butt. 3 times 1 is 3. 4 pi minus 6 pi. 4 pi minus 6 pi is negative 2 pi. And then 3 just comes along for the ride. So look, I have a negative answer. Woohoo! Means I'm done. I got 1 positive one and 1 negative one. I hear chirping, but I don't know where it's coming from. Anybody have a question? Make sure we put your hand up so I don't miss you. What's up, Zach?
All right, so you're cross multiplying, right?
Technically, yes.
So you're not cross multiplying.
I'm multiplying across the diagonals, which, yeah, I think that's cross multiplying.
Okay. So,
This is just if you're fraction phobic. I'm just adding fractions, Zach. So go back to the way you know how to add fractions. You still just find a common denominator. So 4 pi over 3 plus 6 pi over 3 would be 10 pi over 3. Then I did 4 pi over 3 minus 6 pi over 3. That's negative 2 pi over 3. So let's say you're not fraction phobic. You don't need the butterfly. You could just find a common denominator. So let's do this next one. So pi over 12. We're going to add on 1 revolution. That's 2 pi. But you got to give 2 pi a common denominator of 12, which means you're multiplying the top and bottom by 12. 2 times 12 is 24 pi. So this gets us 25 pi over 12. And once again, how did I get that 24 over 12? Well, 24 over 12 is 2, so that's 2 pi chilling right there. I just did the equivalent fraction in my head. So if you're good with fractions, you can just turn it into the equivalent fraction. And then I would just recycle that, because good mathematicians are inherently just a touch lazy. So I noticed that 2 pi, with 12 on the denominator, is still 24 pi over 12. I'm not going to recreate the wheel here. I would just subtract this time. And I would get negative 23 pi over 12. Problem number last is part C there, with regard to this example, and I just did a throwback. Oops, sorry. I just did a throwback to degrees. So just to review, I wouldn't be adding or subtracting 2 pi on this time around. Remember that to find a coterminal angle, when we're in degrees, I feel like I need a darker green. They don't have one. I would do 132 plus 360, because that's 1 revolution in degrees. So we're looking at 492 degrees. To get a negative one, so that's my positive answer. To get my negative answer, I would just subtract 360 degrees. And I know some of you like to stack your subtraction like that. You know, you could also just, you know, do it old school. A lot of you would just keep that negative sign because the 360 is bigger, and then do 360 minus your 132. You go back and you're like, okay, well, carry and borrow from the 5, regroup. You got 8, 2, 2. So we got negative 228 degrees. Alrighty, questions about that? Okay, so how could we apply this now that we have this little gem of information that allows us to find coterminal angles? Like, what good does that even do us? Well, for review. And then what this ultimately does for us, it helps us with example 3, where you're responsible for actually sketching an angle. So this will bring us to the end of this section. What it helps us with is, you know, for instance, 13 pi over 6. I want you to draw that angle. The issue is that's not one you memorized. It's not on the circle. It's not in the diagram we drew the other day. So you got to think of, okay, well, what do I do then? And you might be saying, well, Mrs. Lucas, how did you know so quickly that that wasn't one that I had memorized? Well, let me tell you. See 13 over 6 right here? That's a number bigger than 2. So that's bigger than 2 pi. You see that? So right away, because that number was bigger than 2, I knew it wasn't on the circle. It was not one that you had memorized. So your first step, if it's not one you had memorized, you may want to consider identifying an angle that's coterminal to it that is between 0 and 2 pi. Identify the angle that it would land on the circle, and then that'll help you draw it. So in this case, I'm going to subtract 2 pi. Denominator would be 6. So I'm going to subtract 12 pi over 6. 13 pi over 6 minus 12 pi over 6 is just pi over 6. So, as life would have it, when I go to draw my xy axis, I know where pi over 6 is. I can draw that angle, no problem. That's my 30-degree one. I have that memorized. That's not a problem. So that's pi over 6 right there. So I sketch that coterminal angle. I sketch that pi over 6. The only other detail that I then need to actually make it that 13 pi over 6 that the problem asks is just the direction arrow. So if I go from here to here, that's pi over 6, but I had to go that one whole extra revolution around, and now that guy right there is 13 pi over 6. So you're looking at a quiz for me here pretty soon. You're going to draw some angle measures in. Remember to just include your direction arrow. That's kind of what you're drawing when we ask you to sketch an angle. Part B, 3 pi over 4. That's not bad because that's one you had memorized. Or you're working on memorizing it, right? Maybe. This is example number last, and then I'm done with me DI for the day. 3 pi over 4 is one that I had memorized. So I draw that initial ray in standard position there. And then 3 pi over 4 is just halfway through quadrant 2. So you draw your direction arrow, label it as 3 pi over 4, and you're done. Once again, how did I know it was one I had memorized? 3/4, that's 0.75. That's a number between 0 and 2. It was between 0 and 2, so I knew I had it memorized already. I could kind of figure out where it went. Okay, let's go ahead and take some time to talk about that homework from last night. Hopefully